Assalamu alaikum warahmatullahi wabarakatuh. The descriptive questions of chapter number first. The first question has several parts. We have already attempted the second part. Now the third part is about calculating the volume of any gas at standard condition of temperature and pressure. In the question, I will first read out the question to you. What will be the volume of 60 gram of ammonia gas at a standard condition of temperature and pressure? Now, we are given the mass of ammonia, and the question is asking about the volume. So here, the conversion is very simple. We will convert mass into volume. Very easy. But as you know, we cannot do this directly. We will need the help of mole to do this conversion. So what we will do? We will first convert the mass into moles. And then we will convert the moles into volume. Easy job. We are given the mass of ammonia gas and we are asked to calculate the volume of ammonia gas, 60 gram of ammonia gas at standard condition of temperature and pressure. Now, in the first step, I will have to calculate the number of moles of ammonia gas. For that, I have the formula number of moles mass in gram divided by molar mass. Now, mass in gram is given in the question, which is 60. What I need now? Molar mass. So I can easily calculate the molar mass of ammonia, NH3. Nitrogen is 14, hydrogen is 1, and there are 3 hydrogen. So it will be 17 gram per mole. Now it's very easy. All I have to do is to put the values in the formula. So mass in gram is 60 gram divided by molar mass, which is 17 gram per mole. Gram will be cancelled out with gram and we will be left with 3.52 moles. Now, we have done the first step. We have converted the mass into moles. Now, the final step, we will convert moles into volume, and this is at STP. So we already know about a concept which is known as molar volume, and molar volume is equal to 22.4 dm cube at STP. Standard condition of temperature and pressure, which means that 1 mole of any gas will occupy this much volume at standard condition of temperature and pressure. So we have a formula for this, that is volume is equal to number of moles multiplied by molar volume. We have just calculated the number of moles, which is 3.52 moles, and we already know the molar volume, which is 22.4 dm cube per mole. Now, what we will do our calculation. Mole will be cancelled out with moles, and the answer that we are left with will be 79.05 dm cube. This is the volume of 60 gram of ammonia gas. We can also attempt this question in another simple way, and that is simple ratio. The volume of one, here we will write moles and here we will write volume. 1 mole of any gas at STP will occupy 22.4 dm3. Now, I need to find the volume of 3.52 moles. 3.52 moles. What will be the volume? So it will be X. Now it's a simple ratio. You can solve this ratio. Cross multiply it. X will be equal to 3.52 multiplied by 22.4 dm3. After the calculation, the answer will be the same. 7.79.05 dm3. So this is the answer of this question. In this question, we have learned how to convert mass into volume. But this is only done with gases and only those gases which are given at standard condition of temperature and pressure. If the conditions are changed, then the volume will be different. So keep this one thing in your mind. And the things are very simple. And if there is any question that you want to ask, please write your question in the comment box. I read all your comments and I try my best to answer each and every comment. Please subscribe to my channel, and if you are liking the video, don't forget to share it with your friends and family. Thank you very much for watching.